The photoelectric effect. The photoelectric effect is when a piece of metal is illuminated by electromagnetic radiation. Energy is absorbed by the electrons near the surface of the metal, which liberates them from their bound state. The electrons basically fly off. Now, photons. Photons are discrete packets of electromagnetic energy. Let's take a look at the photoelectric effect in more detail. So before, this is the metal before, we have the incident photon. So we have a discrete packet of electromagnetic energy, so basically light. We have light shining on this piece of metal. So when the light shines on this piece of metal, according to the photoelectric effect, okay, energy is absorbed by the electrons on the surface. So this is an electron here. This electron absorbs this photon of energy and basically it becomes liberated from the surface. So it's ejected or it flies off. Now, there are a couple key points about the photoelectric effect. The first key point, increasing the intensity, so like the brightness of light, increases the number of emitted electrons, but does not increase the speed of the emitted electrons. So when you increase intensity, you increase how many electrons are released, but not the speed. There's a threshold frequency below which no electrons are emitted. Therefore, psi represents the work function and is the minimum amount of energy needed to remove an electron from the material. Every metal has a different psi, or has a different work function. This is how much the baseline amount of energy that you need to release that electron. In addition, different materials have different threshold frequencies and therefore different work functions, as we previously stated. And then lastly, if you increase the frequency of electromagnetic radiation, you will increase the kinetic energy of the fastest electron. This kinetic energy is given by the difference between the energy of radiation and the work function of the material. Okay, we're going to go over this equation in the next slide. But basically, the only thing that affects the speed of an electron is the frequency. So frequency goes hand in hand with the speed. All right, here are two equations. So to determine the energy of a photon, first we have this equation here, which is h, which is Planck's constant, times f, frequency. So energy equals Planck's constant, which is 6.63 times 10 to the negative 34th, times the frequency. And then in addition, kinetic energy of the electron. So this is the electron that's released, so ejected electron. To determine the energy of this electron, we have to take this energy value. So it's essentially how much energy is being shown on the metal minus the work function. Okay, this is the minimum amount of energy. So when you find the difference, that difference goes to the speed of the electron. Okay. The work function is measured in joules, J, and then we have E and kinetic energy max, both also measured in joules.